All right, hello class. Today for day one of our notes, we are learning about transformations. You can read through the definition of transformation here, but the main thing is we're learning about three main types of transformations: a reflection, a rotation, and a translation. So it's important we know what these things are. So reflection, when you take a reflection, so say I have this big old arrow here, its reflection would be just to take it and flip it over. So we could reflect it like this, okay, reflecting it from one way to the other. You could reflect it from top to bottom. Either way, those are a reflection. So when you take a image and flip it, that's a reflection. Rotation, think about tires, they turn. That's what a rotation is, or a tire rotation. So rotation is when you take something and you turn it. You can turn it different numbers of degrees. So you could turn it just like that. That would be 90 degrees. You could turn it all the way upside down. That would be 180 degrees. You could turn it more than all the way around, like 270. There's different degrees you could turn this at. Okay, so that's a rotation. And then translation, that's just when you take a shape and you just move it over. You slide it from one side to the other. Okay, you could slide it sideways, you could slide it up and down, you could slide it at a diagonal. Okay, so that is a translation. Okay, what's important to note when we do any of these transformations, the shape itself may change position and change orientation because it might be flipping over, but it's always going to be identical to the original. It's always going to be the same size as the original, or we could use the word congruent to describe it. So the two figures after these transformations are going to be congruent to each other. Same size, same shape with one another. Okay, meaning all the side lengths and all the angles will all remain equal even after you either translate it, reflect it, or you rotate it. Okay, those all stay the same. So today we're going to focus specifically on reflections. So let me slide my notes up here. All right, so with reflections, you can either have what's called reflectional symmetry within a shape, or you can take a shape and reflect it. So reflectional symmetry, though, first, that's when you have a figure or design has reflectional symmetry if you can draw a line that divides the figure into two halves that are mirror images of each other. Okay, so it's got to be a mirror image. So these pictures right here, okay, each little design in this picture, I could draw a line through it, and one side would be the mirror image of the other. So I would say that this design has reflectional symmetry. Okay, and I could have reflectional symmetry there. I could draw it at a diagonal as long as those are perfectly square there. Then it could fold and it would have to be, again, a mirror image on either side. Okay, so an object has reflectional symmetry if it's a mirror image from one side to the other when you draw that line of symmetry. Okay, so yeah, again, that line is the line of symmetry. Now you can take any object and you can reflect it over some sort of line. So we have this picture right here shows you line reflection. It has, this is my original, and this is called my image, and the object has been reflected over this line of reflection. You'll notice the shape looks exactly the same. It's just flipped over. What you would notice, though, is that every single point is exactly the same distance from that line. So say this was an inch away, this would also be an inch away. Okay, and the A is the same distance from one side of the line to the other side. So every point is equal distance from this line of reflection. Okay? So you can also look at reflections in a coordinate plane. So let's turn our notes over and take a look at that. All right, this is the easiest way to draw reflections is using a coordinate plane because it has it all kind of spaced out for you. So here in this picture, you can see that this shape has been reflected, been flipped over to this side. So when it says what type of reflection is shown, well, in the coordinate plane, there's two types of reflections that we can see. We have two very visual lines of reflection. We have the line, the y-axis, and we have our x-axis. So you can either take an image and flip it over one axis or the other. So you can see when you look at this, that this picture was flipped this way, and it was flipped over this axis right here. And you can see that by every point is the same distance away from that line. This point is 2 away, and this one is 2 away. So we would call this a reflection over the y-axis. So that's what it means by what type is it. So we could have a reflection over the y-axis. We could also have it over the x-axis, but this one's specifically over the y-axis. All right, and we can also draw our own reflection. So it says reflect the triangle ADC over the x-axis, and then label our new points here. So as we look at our triangle, we're reflecting over the x-axis. So this right here is going to be my line of reflection. So we're going to just take every point and put it the same distance on the other side of the axes. So if I look at A, I notice it's just one spot up, so I'm just going to go one spot down, and that will be my new A. Or we can call that, when we draw a new point on a coordinate plane that's after a reflection or rotation or translation, we put this little apostrophe with it. We call that A prime. Okay, so that's my new A. So I went 1 unit up originally, so I went 1 unit down for my new one. Okay, then my C was 2 units up, so right along that same line, I'm going to go 2 units down. That will be my C prime. And then notice the D. The D is right on the line of reflection. So if I flip this over, it's no distance from the line of reflection, so it's going to stay in the exact same place. That's going to be my D prime. Okay, so then if I connect those 3 points, it should look like the exact same triangle, just flipped over that x-axis. Again, with a reflection, every point is the same distance from the line. Okay, and then we could say what the coordinates are, points to all of these are. So we'll notice that A is now at the point -3, -1. Remember, we do our x and then our y. Our C is at the point 2, -2. And then D is right there in the middle at 0, 0. I stay in the same spot. All right, and that's it for our day 1 notes.